All right, so the last video in this series of videos from Module 9 is what happens when we have no solution or infinite solutions algebraically and graphically. So no solution, if we recall from the first video that told us about systems of equations, is when we have two parallel lines. They're going to run side by side forever and they will never cross. Parallel lines have the same slope but different y-intercepts. And then infinite solutions is if we go to graph our lines, we graph one and we graph the other and we find out they're the exact same line. So this will be same line versus parallel lines. So this would be easy to spot if we solved all of our systems by graphing. But most of us are not huge fans of graphing as the first means of solving these things because it usually takes a little more work and time. But it's something we should be wary of. So let's look at this first question, right? This first example. In this example, we have two equations, one that's already solved out for a variable, right? So this is a prime example of when we should be, considering substitution as our way to go. So we have something that's already solved out for t. We can go ahead and sub that in to t in the other equation. So 4 minus 2s, well, that's our t portion, right? Plus 2s is equal to 6. So we've replaced t with what we know t is equal to, which is 4 minus 2s. And then we're going to go ahead and just combine up our like terms. And here's what happens. When we go to combine our like terms, negative 2s plus 2s is just 0. A lot of students don't want to write that. Because they get uncomfortable with the idea of not having a variable anymore. What happened to s? We were solving for s. So what a lot of students will write is that they'll say that this is 4 minus s is equal to 6 and keep going as if they hadn't just canceled out s. But in reality, there are no s's left, so this just tells us 4 is equal to 6. And 4 does not equal 6. So this tells us mathematically that there is no solution. No matter what we plug in, any version, we are not going to get a solution out. So these two lines must actually be parallel. So let's go ahead and graph these just to verify. A little bit harder because these don't have x's and y's. So let's modify these up a little bit. Let's just, for sake of argument, call this y is equal to 4 minus 2x, right? Make all the s's x's and all the t's y's, which makes sense alphabetically. I'm going to go ahead and actually reorder this, right? If this is just 4 plus a negative 2x, it doesn't matter what order I write them in. Oh, God, I added an x on the back though. That was crazy. But this is better. This would let us then graph this because we have our slope of negative 2 and we have our y-intercept of 4. All right, so if these things are indeed parallel, they should have the same slope. So if we wanted to solve the other equation here, what would make sense is for us to do t plus 2s is equal to 6 to solve this also in the same form. So let's go ahead, replace our t with a y and our s with an x, and then we can solve. We'll subtract the 2x from both sides. We get y is equal to negative 2x plus 6. So now we can see this line has a slope of negative 2, same exact slope, but the y-intercept is different. It's 6. So if we were to graph these two different lines, one is going to be starting at positive 6, going down to an over 1, getting us that. And one is going to be starting at 4, going down to over 1 to get us a line that runs right next to it forever and ever and ever and never crosses. So that's what it looks like when you get no solution. What's going to happen if you're doing substitution, your variables are going to cancel and you're just going to be left with an untrue statement. Now, the other example. Here, our equations are set up for elimination. Definitely our better way to go here. And when you're first glancing at this, you probably go, okay, y looks like it's the easiest thing to cancel. I know I can make this positive 2 into a negative 6 if I just multiply through by a positive 3. So I can rewrite this equation by multiplying through by that 3. Once I have that equation, I'm going to go ahead and rewrite the first one below it, since they're not lined up anymore. And look what's about to happen. When I go to do my elimination step, I got more than I could bargain for, right? I didn't only cancel the y's, I canceled the x's as well, meaning that this whole left side is just 0. There's nothing left over there. And on the right side, 15 minus 15, oh crap, they cancel too. 0 is equal to 0. What is happening, right? What? That's a crazy face. What in the world is going on? Since this statement is actually true, this equal sign is true, this is telling us that basically any solution to the first equation is also a solution to the second equation. This tells us that there are infinite solutions. So they're the same line, and we have infinite solutions. The classy way to write this in terms of math is to write any point, so any x and y, as long as that x and y, so we're going to use that line, as long as that x and y is on the line. So we're just going to write whichever version of the line we like better. I'm just going to write the top one because it's on top, even though it's a bigger version. So this is the actual way that you write the solution to this. We will not be tested on that on the exam, but I just want you to know that this is what you write, because you don't really want to say that it's negative infinity to infinity. It's not any numbers, because it's only the points on the line. And if we were to actually graph this just to verify and see, let's go ahead and graph. Ugh, part of me does not want to graph. We would have, let's do the first one, negative 12x minus 6y is equal to negative 15. Bad things are going to happen to us with graphing this, but I'll do it. In fact, actually, you know what? I'm going to go ahead and do this on Desmos, just because I don't really want to graph this thing that and the reason being that my intercept is going to end up being a fraction, and I'm not looking forward to that if I try to do slope-intercept form. So I've written them both down, and we'll just do a quick little breakout to Desmos to see what's happening. So let us go to Desmos. Okay, so let's go. I go to Desmos.com. Boom. Let's do it. All right, Desmos.com is an online graphing calculator. Basically, it allows you to do even cooler graphing, because your graphing calculator, you have to have everything in y equals form. With Desmos, you don't. So it's actually even more useful than a graphing calculator. So, oops. You can't see everything I'm typing here because my screen is a little off-centered, but I'm going to just write in that first line, 12x minus 6y is equal to negative 15. I'm going to hope that that works out, so we'll try it. You're really not going to write anything there. 12x plus 6, oh, it's a minus 6y. I still just want to see if it'll enter anything there. All right, this is not working. I'll have to type it in. 12x minus 6y is equal to negative 15. And the second line was a negative 4 plus 2y is equal to 5. Oh, I lost an x. X. Cool. So now you can see I can actually, I wish I could move this recording screen, but I can't. On the side in Desmos, you actually have the ability to turn on and off certain colors of graphs. So right now I'm just clicking on and off that first graph. It hates me, but you can see it's the exact same graph as the red one. So that's how you could double check using technology. Desmos is also a great way to double check all your answers when you're doing your WebAssign, and visually just see that what you're doing with your algebra is working out. So hopefully that helped a little bit. For both of these versions, what's going to happen, all of your variables will cancel and you'll just either get an untrue solution, which means you have no solution, untrue equation, or you'll get a true equation, which means you have the same line and there's actually infinite solutions.